On to our sixth video, let's build them triangles. But before we do, let's recap. Here's some information here. We got our SOHCAHTOA. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. And we're talking about right triangles, so we have the idea that a squared plus b squared equals c squared. The Pythagorean Theorem. So I drew a little triangle out with a's, b's, and c's. A's and b's are arbitrary, but according to here, our opposite is b, our adjacent is a, and our hypotenuse is c. So c is always going to be the hypotenuse for us, don't worry. But we could now look at this and go, well, sine is just b over c, and cosine is just a over c, and tangent is just b over a. We're just replacing opposite with b and adjacent with a and all that stuff. So no big deal. So we're going to use this as a triangle. So let's go into our common angles here. So let's build our first triangle. I'm trying to make it look same. So we're going to say that this is 45 degrees. And now how much is, can you tell if I give you a 45 degree angle right there what the other angle is going to be? Do you know what it's going to be? It's going to be 45. Because with a right angle, whatever these two angles are, they are what we call complements. Complements add up to be 90 degrees. So we have a common angle. And I want to make the hypotenuse equal to 1. Now what we're doing is we're building up angles for 45 degree angles. These are just 45 degree angles. And we want to see. So now we have an a and a b that we have to solve for because we want to know. Our whole game here is we want to know what's sine of 45 degrees, what's cosine of 45 degrees, and what's tangent of 45 degrees. That's why we're doing this. These are what we call common angles. There's a common angle for 30, 45, and 60. Those are everything for us. Not having those memorized on your midterm, let me be very blunt with you. Once we get to this point, our 30s, 45s, and 60s, if you do not know those values for sine and cosine, please just take the day off on the midterm. You'll never pass in a million years. I've designed them to where you have to know these values. So I want to tell you right up front and tell you that, hey, we have to have these values memorized. But I'm going to make a table for you and make it real simple because there's only 5 numbers we have to memorize. So, all right, back to it. If both of these angles are the same, do you know anything about the two sides? Can you figure out anything about the two sides? If the angles opposite are the same thing, what do you think about the sides? Now, I don't want to take you back to geometry. Well, it means that A equals B. They're the same gosh darn thing. If they're opposite the same angles, they must have the same sides. It's got to be. It's got to be true. And I'm not going to take you back into geometry and prove any of that. So what I'd like to do is instead of writing it as B over here, let's write it as A. They're both A. It's the same thing. Now let's use the Pythagorean Theorem so we can solve for what A might be, so then we can solve for our opposite over hypotenuse. We don't know what the opposite is. We want to know what the adjacent over that. We don't know what the adjacent is. We got to solve for it. So since A is equal to B, when we go and use our formula, we're going to say A squared plus, instead of writing in B, we're going to write in A again. So A squared plus A squared is equal to 1 squared. Pythagorean Theorem, we get really good with this. So, all right, how do we do this? We got 1A squared. We're going to add it to another A squared. I believe that gives us 2A squareds is equal to 1 squared. But 1 squared is just 1. Please don't leave 1 squared or square roots of 1. They equal 1. Now we'll divide by 2 because we're trying to solve for A. And we're like, A squared is equal to 1/2. Now we need to hit this with a square root. Typically, when you hit something with a square root, you need a plus or a minus, but we're just talking about lengths. So we're going to say that A is equal to the square root of 1/2, but I don't like that. Did you know this is true? That's the square root of 1 over the square root of 2. I'm going to bust myself right now. I was in calculus, and I didn't know that was true. So if you didn't know it, no biggie. You're in trig. Your teacher was 2-3 classes ahead of you and didn't know this. So hopefully you can be better than me. Well, the square root of 1 is 1 over the square root of 2. And now let's talk about rationalizing. I know the algebra review videos discuss it. Now, you never have to leave an answer rationalized. I'll never ask you to leave an answer rationalized. That means no roots in the denominator. But you have to know how to. And this is going to form a nice pattern. So if you want to get rid of the root in the bottom, see there's a root 2, we're just going to multiply by that, whatever that number is, top and bottom, because we're just multiplying by 1. The square root of 2 divided by the square root of 2 is 1. You can multiply anything by 1, can't you? So we found out that our a value, 1 times root 2, is root 2. Root 2 times root 2 is 2. So we just found that our a values are the square root of 2 over 2. Cool. Well, let's look at sine. Sine of 45 is going to be the square root of 2 over 1. The square root of 2 of, isn't that just the square root of 2, or square root of 2 over 2 over 1? So it's just the square root of 2 over 2. Okay, now let's look out of this angle so we can figure out what cosine. It's the same thing. It's equal to the square root of 2 over 2. And then what's tangent of 45? Well, that will be our opposite over our adjacent if we're coming from this one. So it's the square root of 2 divided by the square root of 2 over 2 divided by the square root of 2 over 2. Look, it's sine divided by cosine. It's sine divided by cosine. It's sine divided by cosine. Same picture divided by the same picture, that's equal to 1. And there's our 3 values for a 45-degree angle. Don't worry, we're going to recap this at the end. So I'm probably going to hit about 12 minutes on this video. Now let's make one more. Don't worry, don't memorize that thing up yet. We're going to have it. Now we want to make another triangle. But I want to make it a very special type of triangle. Very special. I want to make this one 30 degrees. So what would the other angle be? If one's 30, I've already told you earlier. Do you recall it? But I talk a lot. They have to add up to 90. 30 plus what equals 90? And that's 60. So we want to mess with this triangle here. That's what we want to get memorized. But in order to do it, we're going to do a little something different. I'm going to make a non-right triangle with all the angles being 60 degrees. And we want to try and make that triangle there. Well, if all the angles are the same, does that mean all the sides are the same? I think it means all the sides are the same. If all the angles are the same, that means all the sides opposite must be the same. So let's make all the sides. Let's make it a number. We can go with 1. 1 will work. We can make it 2. We can make it 3. We can make it 4. But I've done these about 100 times. I want to make this 2. Let's make all the sides 2. Just randomly chose. Let's make it 2. But what this allows us to do, since all the angles are the same, we can do what's called drop a perpendicular. We can drop this down to the bottom. Now, not to scale. I know my stuff looks like it's not cutting it. But since all the sides are the same, doesn't this make this a 30-degree angle and this one a 30-degree angle? We cut it in half. And doesn't it make the 2 sides here 1 and 1? So let's just look at one of the triangles. Sorry, not to scale. 1, 2, 60, 30. And then we just want to know what's this opposite side from 60. And it's okay if you're not catching all this. You're not responsible for building this. But if you do catch it, oh, that's going to be great. It'll help you to understand things in the future. So now what we need to do is use our Pythagorean theorem. A squared plus b squared equals c squared. And let's solve for b. So we take it aside and we're like, all right, 1 squared plus b squared is equal to c squared. 2 squared. So 1, right? 1 squared is 1 plus b squared is equal to 2 squared, which is 4. Let's subtract over our 1. And we get that b squared is equal to 3. So now let's hit it with a square root on both sides, and we get b is equal to the square root of 3. Do you know the square root of 3? I don't either. Please don't write down 1.7. That's not exact. Exact is root 3. So let's not use them decimals. So now we can look at this and go, oh, it's the square root of 3. Well, let's start solving. Let's go get sine. Let's get cosine. We're just looking at this bad boy right here. Excuse me. We're just looking at that triangle there. Let's see if we can't find sine of 30 degrees. Well, from 30 degrees, the opposite is 1. The hypotenuse is 2. So sine of 30 is a half. Let's do cosine of 30. Well, cosine of 30 from this angle, we're going to take the adjacent over the hypotenuse, and we're going to get the square root of 3 over 2. And then we get tangent of 30, which is just going to be the numerator of sine divided by the numerator of cosine. Oh, I'm sorry. So it's from 30 degrees, it's the opposite, 1 over the square root of 3. Oh, that's the same thing we would have got from back there, but learning that trick's kind of cool. Neat. And I don't want to talk about the other reciprocal functions. There we go. We got sine of 30, cosine of 30, tangent of 30. This is true for every time. Sine of a 30-degree angle, always 1/2. Cosine of a 30-degree angle, it gives us a ratio of the triangle of root 3 over 2. It's true every time. And now we're going to do our sine of 60, our cosine of 60, and our tangent of 60. Let's go get the other angles, because 30, 45, and 60 are the three angles we got to be pro with. There's more than that, but I'm minimizing. All right, so now we're going to look from, 60. Sine of 60 is the opposite over the hypotenuse, or square root of 3 over 2. Oh, weird. That's like the same thing as cosine of 30. Well, there might be something tied there. Complementary angle theorem. Now we're going to look at, okay, cosine of 60 is going to be the adjacent over the hypotenuse, so that's 1/2. Oh, weird. That's the same thing as sine of 30. It's like if you just look at it different, they're the same things. So I'm guessing our tangent is just going to be the numerator of sine divided by the numerator of cosine, square root of 3 divided by 1. But let's just look at it. We're like, okay, cool. 60, we have our opposite, square root of 3, over 1. Oh, it is just the square root of 3. You could write over 1 if you want to, but, I mean, what are we going to do? Come on, man. There we go. Then we got some values. Now, I didn't rationalize this one. You might see it sometimes. It's also the square root of 3 over 3, but I never write it like that. But your text will. Square root of 3 over 3. It's the same thing. So I think we should stop here, and then we're going to put it all together. And put it in a table for you, and we'll do a little bit of memorization games. All right, see you in a minute.